All right, so this first one says, and I don't like when they do this capital F and lowercase f, keeping these straight. I tend to sort of ignore that and just jump straight to the problem because it always boggles my mind why they make them the same letter. But f prime of x equals f of x, so that's the antiderivative for all numbers then, and we're going to need to do a u substitution for what's inside the function. So u is going to be 2x. Derivative will just be 2 dx, and we'll need to adjust it with a 1/2. So the only thing that we get to substitute out there is the dx. So 1/2 is going to go out front, du is going to go at the end. Weirdly, this is what's left inside of the function, and then I just need to fix the boundaries. So if I plug in 1 for x here, 1 times 2 is going to give me 2. And if I plug in 3, 3 times 2 is going to give me 6. So when we do this antiderivative, it's going to be the capital F of x. So upper boundary minus lower boundary, we're going to have 1/2 f of 6 minus 1/2 f of 2. Okay, Jason, thanks for letting me know. I will let her in when she gets here. And then we can't figure these out because we don't have like a table of values I can look these up in. So I think that's just the answer, isn't it? E for that one. We couldn't go any further because we don't have this function and we don't have any values for that. All right, so number 2. They tell you what to let u equal, but it's going to be that inside part. So u is 2x plus 1. And that derivative is just 2 dx. And so again, we're going to adjust with a 1/2. So once again, the only thing that I get to substitute out is the dx. And in its place, I'm going to put 1/2 du. So what's still there is square root of u, and that's what's in every single one of these choices. So they all have that. We just need to adjust the boundaries. So if we plug in 0 for x, we're going to get 1. And if we plug in 2 for x, we're going to get 5. And they didn't ask us to go any further. They just wanted us to do the substitution. So finding that answer, this one is C. All right, for this one, we're going to have to let u equal this exponent, negative 4x. And so that derivative is negative 4 dx. And we will adjust with a negative 1/4. So again, the only thing we're going to be able to substitute out is the dx. So we'll have negative 1/4 out front, du at the end, and what's still there is e to the u. So that is its own, oh, I need to adjust the boundaries, hold on. If I plug in 0 for x, I'm going to get 0. And if I plug in 1 for x, I'm going to get negative 4. So the nice thing about e is it's its own derivative and it's its own antiderivative. So this will be negative 1/4 e to the u, and we just have to evaluate upper boundary minus lower boundary. So if I plug in the upper boundary, I'm going to have negative 1/4 e to the negative 4th minus, and then it would be negative 1/4. So those negatives are going to cancel. 1/4 e to the 0, which is just 1. So they're not going to write that in the answer since that's just 1. And then also this negative exponent can be brought back down to the denominator. And so, but they didn't do that. They left it e to the negative 4th. I never know how far to simplify until I start looking through the choices. And they also wrote this back the other way. They put the positive 1/4 in front of it. So your answer choice for this one is D. All right, for number 4, we're going to let u equal 1 plus sine of theta. And if all these thetas bother you, theta is just another variable. If they bother you, you can scribble them out and put an x instead if that's what you'd prefer. It's just the variable we usually use for the angle. So 1 plus sine of theta. Derivative of that. Derivative of 1 is going to be 0, so that's gone. Derivative of sine is cosine. And then d theta. So we actually don't have to do an adjustment to that one. We're going to substitute out the cosine and the d theta. And so what is left is nothing in the numerator, so just a 1 over square root of u. 1 over square root of u, I am going to write as u to the negative a half. Negative because it's in the denominator, and a half because it's a square root. And then I just need to adjust the boundaries. So if I plug in 0, sine of 0 is 0, plus 1 will give me 1. And if I plug in pi over 2, sine of pi over 2 will be 1, plus 1 is 2. So then the antiderivative, I'm going to add 1 to this power, so it'll now be a positive 1/2. And then dividing by a half is the same as multiplying by 2. So I'm going to have a 2 out front and evaluate from 1 to 2. So if I plug in 2, 2 to the 1/2 means square root of 2 minus, and then if I plug in 1, square root of 1 would just be 1, and then times 2 would be 2. And then looking at the choices, it looks like they factored out a 2. So if you factor out a 2, you'll be left with square root of 2 minus 1. So that one is D. All right, for number 5, we've got this fraction here. What I would do is rewrite this and just divide through by the x. So x squared divided by x, that's just going to be 1x. And then it will be minus 1 over x. And then I would just do it as 2 separate terms, just 2 separate problems. So antiderivative would be 1/2 x squared minus, and then antiderivative for 1 over x would be ln of x. Which the e was kind of a hint there that we were probably going to end up with an ln at some point. So upper boundary, that would be 1/2 e squared minus ln of e. They will cancel, and that will just be 1. And then plugging in the 1, that will give us 1/2 minus ln of 1 will be 0. So let's see, this would be 1/2 e squared minus 1 minus a half would be minus 1 and a half, so minus 3/2. So that one is E. All right, number 6, we are going to have to complete the square for this part in the denominator. Finding the antiderivative means we're going to need to do an integral. So completing the square, you're going to take this middle term, divide it by 2, and square it. So 2 divided by 2 would be 1, squared would be 1. And then you have to adjust that so that you're not changing what's in the problem. You're not allowed to just go around changing the problem. So I need for it to still be a +2. I changed it to a +1, so I'm just going to add another 1 so that I haven't altered the problem at all. And then the whole point of doing that is you can now write this part factored. So if you factor that, you're going to get x minus 1 squared. And then this will now follow your pattern for arctangent. So A is always a value. So that would just be 1. And U is always taking the place of the variable. So that would be this part, the x minus 1. And derivative of x minus 1 is just 1 dx. So we don't have to make any kind of an adjustment there. So it ends up being integral du over u squared plus a squared, which if you actually want to skip this step, you can if you just know it's going to be arctangent. But this just is the arctangent pattern. And then it's 1 over a, but that would just be 1 over 1. So I didn't forget to write the fraction out front. It's just, it was going to be 1. And then it is u over a, and anything over 1 is just going to be itself. So that'll just be x minus 1, and then plus c. Oh, and they didn't put the plus c, which makes me really mad, but this would be e. And I guess as soon as you got to this step, to be honest, if you got here and realized it was going to be arctangent, you could honestly just stop and pick your answer. And I'm not telling you that to like tell you to be lazy, but the AP exam is timed. So you don't want to take time to do stuff if you can just pick your answer. All right, here we're going to add 1 to the power. So that would make that a 3/2. And then out front, we're going to need a 2/3 and evaluate from not 1 to 3, 0 to 3. And if you're like, hey, what happened to the u substitution? It's there. You just don't need to write it out for this one. You can if you want to, but u is just going to be x plus 1. And that derivative is just 1 dx. So there's no adjustment that needs to happen there. Now, if it was a 7x plus 1, we would need a 1/7 out front or something. But if it's not going to need an adjustment, you can actually get away with skipping that. Again, I'm not trying to tell you to be lazy, but this exam is timed, so you want to save as much time as you can. All right, so plugging in 3. 3 plus 1 is 4. So this will be square root of 4 cubed. That's what 3/2 means. And we're going to have to get the whole way through this without a calculator because they simplified all these choices now. Minus 2/3 times, now if I plug in 0, that's just going to be 1. So it'll be square root of 1 cubed. So square root of 4 is 2. 2 cubed is 8. 8 times 2 will be 16. So 16/3 minus, now this is just all going to be 1. So 2/3, so 14/3. So that one is D. All right, and then last one, we're going to let u equal this inside part. And so that derivative is negative 2x dx. And I'm going to adjust with a negative 1/2. So I get to substitute out the x and the dx. And in its place, I'll put 1/2 or negative 1/2 du. And what's still there is square root of u, which I will write as u to the 1/2. And then antiderivative, we'll add 1 to the power. That means I need a 2/3 out front, but there's a negative 1/2 there, so don't forget that, plus c. So simplifying these fractions, the 2's are going to cancel, so it'll just be negative 1/3. And then u was 4 minus x squared. And it looks like in the choices, they just left it to the 3/2. So I'm just going to leave it that way. So let's see, which one is this going to be? Negative 1/3, 4 minus x squared to the 3/2 plus c. That'll be e.